All right, well, congratulations, class. We have officially passed the halfway point in class. The midterm was in the middle of the semester, so we're ready to move into the second half of the class. And really with this, what we're going to focus on is getting into more engineering and some more design work using the CAD that we've learned in the first half as a tool to do some more engineering work. So I wanted to talk to you a little bit about the next four modules that you're going to be working on. This is going to cover 4 weeks. Okay, so each module is going to be 1 week in length, but I'll go through all of these now because they're all similar, all of a similar format. So, these you can kind of work on as you get better and better with the skills that you're going to be using here. So we're going to be starting with simulation studies, okay, engineering analysis, computer-aided engineering. And the first module is the static stress analysis. Okay, so let's look at these, and you can see the static stress analysis is the first one. This is due October 25th, so it's due a week from Sunday. All right. Now, for each one of these, the format is going to be more or less the same. Okay. What I've provided you is a lot of support material, a lot of videos and other information that you'll need to work on these. Frankly, I think the videos, the tutorials, and the demonstrations are going to be sufficient for you to get this. But we have in the static stress assignment, there's first some reading on getting started with FEA. FEA, of course, stands for Finite Element Analysis. And it's a key factor in engineering analysis, something undoubtedly you will encounter later on in your engineering career, whether you're going into mechanical engineering or civil engineering or anything along those lines. So there's a background video here where you can find out more about finite element analysis. In particular with Fusion. I haven't mentioned this yet. I should have mentioned this earlier, but Fusion, one of the great things about Fusion 360 as a CAD tool is that it's not just a CAD tool. It is a engineering analysis tool. So we're going to stay with Fusion and we're going to do our simulation studies with and within Fusion. Okay. So our static stress analysis is going to be done inside of Fusion. So I have 3 tutorial projects, the wrench, the rocker arm, and the wheelie bar, okay? These are full projects, okay, that you can work on as practice. You can see right here that this is an ungraded tutorial intended to give you practice for doing these. I strongly encourage you to do these. I know the tendency is to say, you know what, I'm not going to do these practice things. Let's just get to the main point, but I strongly encourage you to do these practice problems. They're not long, and you will, get lots of practice. The procedure for doing the simulation studies with Fusion, they're kind of straightforward. You go through different steps, step 1, step 2, step 3, like that. But it can be a little bit tricky. So that's why I put these out here for you to work on. The static stress assignment that you're going to be doing is a stress analysis of a centrifuge rotor. Okay. So here's the assignment right here. I won't go, much more into this because you can read this. And then there's a quiz. Okay. So based on your results from the centrifuge stress analysis, you're going to take this quiz, and that's going to be what you're graded on. Okay, the quiz is going to be based on the analysis. You will want to have your stress analysis results open when you're doing this. So this isn't a quiz that's kind of like closed book, closed notes, or anything like that. It's more of, quiz is kind of an imprecise term. It's more of a assignment review where you're going to answer questions based on the static stress analysis that you perform. Okay, so that's the first one, simulation static stress analysis. Now, the second one is what we call a modal analysis. This is also a frequency analysis, or you can also call it a vibration analysis. Basically, we're going to be looking at things in Fusion and see how they vibrate, what kind of shape and frequency they vibrate at when there's some force applied to them. Again, same format. Okay, so I give you 3 tutorial projects: a modal beam, fan blades, and a centrifuge. These are these are ungraded, but again, get into these and get these done. You'll feel a lot better when you're doing the assignment, which is a tuning fork. Okay, and again, there is a quiz, which is meant to be answered with the modal frequency analysis assignment up and completed. It's more of like a assignment turn-in sheet. Okay, so that is due November 1st. So that's another week after the static stress. Okay, moving on to that, then we have a thermal analysis. The thermal analysis assignment is where we basically take an object in Fusion and we apply a heat to it. And we want to see how the object is going to respond to this heat that we applied to it. How is the heat going to move through the part? Is it going to distort? Things like that. Again, I have 3 ungraded projects for you to practice with: a multi-layer pipe, heatsink, and pipe hanger. And then you can get into the assignment that's graded, the brake rotor. This is due November 8th. So again, another week after the modal analysis. The final assignment they're going to be working on, I think, is definitely the coolest. Topology optimization is something that probably you haven't heard of. It would be awesome if you did. But basically what topology optimization is it's a way that we can let the computer determine where we want material in a part and where we don't need material in a part from a structural point of view, from a stress and strength point of view. So it's really a way for us to let the computer guide us in how our objects are going to look, so that we can cut down on material that we don't need, cut down on weight that is unnecessary, make sure the part is as efficient as possible. It is a super cool new technology. And I say new, it's been around for a while, but it's really moved into the forefront with the advent of more powerful CAD. Fusion 360 does topology optimization within it. And so I hope and I think that you're really going to like it. It's just a really cool thing to play around with. There's only one tutorial project here ungraded, and that's the wheelie bar. And then you're going to get into the assignment itself, which is a gripper topology optimization. Okay, so you have the quiz again and the assignment. This is due November 15th. So again, a further 1 week after the thermal assignment. Okay. So I think, in wrapping all this up, there's basically 4 simulation study assignments that you're going to be working on. Each one is going to be paced or separated by a week, which frankly is bordering on too much time. But I'm giving you too much time because I really want you to practice with these, do the ungraded parts. I think you'll find that they're enjoyable. They're really going to push you in the engineering and give you some skills that you can carry forward into your later courses that you take in engineering. Okay, so that's going to take us through to the final project, basically, and we're also going to, at that point, get into the engineering design process. So I'm not going to talk about that right now because we have a whole month to get through these things. So that's it. If you have any questions, please, let me know. Email me. If we need to, we can do WebExes. Have a good weekend. It's Saturday, so have a good weekend and a good week. And I'll talk to you shortly. All right, bye.